Okay, October, November 2022, paper 1, variant 2. Question 1. Which instrument can be used to find the volume of a small stone? To find the volume, you need a measuring cylinder with some water. Question 2. The diagrams show speed time graphs for 4 different bodies moving for 6 seconds. Which body traveled the least distance? Least distance, so we need to calculate the area under the graph for each graph. It's quite obvious that C and D have larger areas, so we can cancel out C and D. Is it A or is it B? We need to calculate the area under the graph. For A, it would be half times 6 times 8, which is 24, if I'm not mistaken. For B, we can calculate two triangles. First one would be half times 8 times 4, and the other one would be half times 4 times 2. Okay, so this would be 4, and the other one would be 16. 16 plus 4 is 20. Total area is 20, which is less than 24. So B would have a less distance traveled. Which row shows the mass and the weight of an object near the Earth's surface? The mass, okay, you just need to multiply by 9.8. So 0.2 times 9.8 is not 0.2. 2 times 9.8 is not 0.2. 2 times 9.8 is almost 20. So it is C. Diagram shows 4 pieces of laboratory apparatuses. Which pieces, okay, are used to find the density of a liquid? To find the density of the liquid, you need a balance and a measuring cylinder. You do not need a ruler or a stopwatch. Measuring cylinder and a balance. What's the unit of a force? Moment of a force about a point, Newton dot meter. On which ball is a non-zero resultant force? Non-zero resultant force. What do I mean by non-zero? There's a force acting on the ball. We need one of them to have a resultant force acting on the ball. Constant speed, zero resultant force. At rest, zero resultant force. Floating, zero resultant force. The only one would be C, free falling. Okay, just been released. If it had been just been released, means that it's still accelerating. Which statements must be correct for an object to be in equilibrium? It has to be moving in a straight line? No. There is no resultant force? Yes. No resultant moment? Yes. 2 and 3. An object falls towards the Earth's surface. What happens to the gravitational potential energy and the kinetic energy? As it falls down, the gravitational potential energy decreases and the kinetic energy increases. It would be B. Which source of energy is not currently used to generate electrical energy? Not currently used. Nuclear fusion. Nuclear fusion. This nuclear fusion is in the sun. Okay, the sun and stars, they use the nuclear fusion. On Earth, we use something called the nuclear fission. Okay, on Earth, we use nuclear fission, not nuclear fusion. Okay, and again, you can cancel out the other ones. You know that we can use the waves, we can use the tidal, we can use the solar, but the only one is the nuclear fusion. We do not use it yet on Earth. A mass is lifted from rest, okay, on the ground to Y. There is no air resistance. P is the increase of gravitational potential energy. Q is the kinetic energy. What is the expression about the mechanical work done on the mass? As it moves upwards, the gravitational potential energy increases, and as it is moving, it has some kinetic energy. So basically, the total work done, the total energy of this object is now equal. The total energy of the object is now equal to what? It's equal to the gravitational potential energy and the kinetic energy of the object. Whatever the kinetic energy is, or whatever the gravitational potential energy is, we'll just add them up to find the total energy, the total work done on this object. Okay? A pressure gauge is lowered into the sea. Which statement describes how and why the pressure changes as the gauge is lowered? When the gauge is lowered below the surface of the sea, what happens? The density of the seawater decreases? No. The depth of the gauge below the surface of the sea increases, so the pressure increases. Okay, this sounds right. The height of the gauge above the sea decreases? No. The temperature, it has nothing to do with the temperature, so it has to be B. Hmm. The pressure of a fixed mass in the cylinder is measured. The volume of the mass, okay, the volume, sorry, of the gas is slowly decreased. When you decrease the volume, you know that the pressure has to increase. The pressure, okay, increases. When you decrease the volume, okay, they are both inversely proportional. They are inversely proportional. So when the volume decreases, the pressure increases. So should it be B or C? It cannot be B. Why can it not be B? Because the pressure does not start from zero. The pressure of the air isn't zero. The pressure of air is the atmospheric pressure, which is around 100,000 pascals. So at this point, it should start at around 100,000 pascals. You're not required to memorize this number, but I'm just saying that air has an initial pressure, which is what? Which is 100,000 pascals. So if you're going to increase the pressure, you have to increase this pressure above whatever initial pressure it already had, which was 100,000 pascals. It will not start from zero, and definitely it will not decrease or stay the same. Which statement about the motion of molecules describes the process of evaporation? Molecules escape from the surface of the liquid. This is quite easy. Um, Thermometers have been cancelled. Okay, but if you want to know that the lower fixed point would be zero, the upper fixed point would be 100. But this question is cancelled. What happens to a solid when the temperature increases? The temperature, its internal energy increases. Again, you can cancel out the other ones. When the temperature increases, it actually expands and the density decreases because the volume increases. The molecules move freely. No, it's still a solid. Mm. A piece of equipment is designed to produce a type of electromagnetic wave. Which of them can produce an electromagnetic wave? Not an electromagnet. It will produce a magnetic field. Electric motor will produce kinetic energy, which is not a wave. Electric generator, again, it will produce electrical energy. Electrical fire. uh, What type of electromagnetic wave does it produce? It can produce two types of electromagnetic waves, infrared and visible light. It can produce two types of electromagnetic waves. Particles can move, transferring thermal energy as shown. In which states of matter does this movement occur? In gases and liquids only. Can never happen in solids. What's the name of this effect? This is diffraction. Quite easy. What are the correct labels for the diagram? This would be the object. This would be the image, and he needs the principal focus, which is Y, F. So W, Z, and Y, B. Diagram shows an object in front of a mirror at which labeled position is the image. If this is the object, then basically the image should be at B. What's the angle of incident? Ah, the angle between an incident ray and the surface of a plane mirror is 70 degrees. What's the angle of incidence? Again, the angle between, okay, let's, if this is the mirror, for example, the angle between the incident ray and the mirror is 70. So the angle of incidence, which is between the ray and the normal, would be 20. How did I calculate 20? 90 minus 70, which is 20. This is the angle of incidence. Visible light has a frequency of approximately 5 times 10 to the power 14. M and N are two other types of electromagnetic radiations. The frequency of M, 5 times 10 to the power 6. Frequency of N, 5 times 10 to the power 15. Let me write them down. RMI, Rami, looks great. Okay. L has a frequency of 5 times 10 to the power of 14 hertz. As we move from radio waves all the way to the gamma rays, what happens to the frequency? The frequency increases. So N has to be somewhere after the light. It should be N. This should be N. Either ultraviolet X-rays or gamma rays. And M has to be somewhere before the light. This should be M. Why? Because it has a frequency less than 5 times 10 to the power 14. This is 5 times 10 to the power of 6, and this is 5 times 10 to the power of 15. So let's choose. M could be radio waves. Okay, it cannot be ultraviolet or X-rays. N could be ultraviolet. It cannot be infrared. So the only right answer would be B. Two students are describing the different types of electromagnetic radiation. Which row shows the possible type of radiation that each student is describing? Student 2, the radiation is in remote controllers. So we know that this one is the infrared radiation. So the only right answer would be A. Communications, we can use microwaves, yes. A 100-meter race is started by firing a gun. When does the finishing judge see the smoke and when does he hear the bang? He sees the smoke almost immediately. He hears the bang not almost immediately, but after around 0.3 seconds, because the sound is much slower than the light. An electrical hair dryer is rated at 230 volts, 2 amperes. Which circuit could be used to check that these ratings are correct? Basically, D. You cannot have an ammeter in parallel, you cannot have a voltmeter in series, and you cannot have an ammeter in parallel again. Diagram shows a circuit. The variable resistor is adjusted until the potential difference is 6 volts. The current is 0.5 amperes. What's the resistance? R equals V over I. V is 6 and I is 0.5. The total resistance would be 12 ohms. What are the units of electromotive force? Volts. EMF is volts. Plastic rod is rubbed with a woolen cloth. The rod becomes positively charged. Rod becomes positively charged means that it loses electrons. So electrons move from the rod to the cloth. Can never move any protons. Circuit containing a cell. In which position does the voltmeter measure the potential difference of the lamp? Potential difference of the lamp. C. Diagram shows a potential divider circuit. The temperature of the thermistor increases. Again, when the temperature of the thermistor increases, what happens to the resistance? The resistance decreases. What happens to the voltage? The voltage also decreases. So the resistance decreases and the voltmeter reading also decreases. Again, the temperature and the resistance are inversely proportional. So when the temperature increases, the resistance has to decrease. Okay? Okay. A student sets up 4 circuits using identical batteries and 3 identical lamps. In which circuit will all the lamps be the brightest? The brightest would be in D because they are all in parallel and they will all have the same total resistance. Sorry, total voltage, I'm sorry. Which diagram shows the circuit symbol for a fuse? D. If the insulation with the mains cable becomes damaged, 2 of the wires may touch and cause a short circuit. When a short circuit occurs, what happens? The current will increase. Okay, the current will increase. So the danger is that the large current will overheat the wiring and lead to a fire. How can I prevent this? Using a fuse. Using a fuse. Okay. 4 small compasses are placed around the solenoid. Current is now switched on in the solenoid. This solenoid will now act as a magnet. For example, it would have north and south poles. We know for a fact that when you have compasses around the north and south poles around the magnet, 2 of them will face one direction and the other two will face the opposite direction. For example, two of them will face to the left, okay, and the other two will be to the right. You cannot have them looking up and down, such as this. This is wrong. This is, okay, definitely wrong. So is it C or is it D? Okay, C is wrong. Why is C is wrong? You cannot have one of them looking to the left and the other looking to the right. It will only be D. Okay, it will definitely be D. Okay, in this case, the magnet. Okay, this is the North Pole and this is the South Pole. Okay, this is the North Pole and this is the South Pole. Why? Because the North is attracted to the South Pole again, and the magnetic field lines are looking this way. Okay, and the field lines are facing this way. Transformers are used in the transmission of electrical power to houses. Which type of transformer is used at the power station prior to the connection? Which is used prior to the houses. The power station, you have to use a step up, and before the houses, you have to use a step down. Why? Because the voltages are too high. The voltages in the power lines are too high. When the voltages are too high, what happens? They could electrocute it. So you need to step down the voltage to, for example, 220 or 230 volts, so that we can safely use them in the houses. The diagrams show the coils of two simple direct currents. Coil P has three turns, and coil 2 has two turns. What produces the greatest turning effect? Coil P definitely will produce the greatest turning effect with a higher current passing through it. You need to increase the number of turns, you need to increase the current, and you need to increase the strength of the magnetic field. The nuclide of cobalt contains 27 protons and 32 neutrons. Which symbol represents this nuclide? 27, 27. It cannot be B. Why? Because you do not write the number of neutrons. You actually write the mass number, which is 32 plus 27. Everyone is exposed to background radiation. What are sources of background radiation? Food, rocks, and cosmic rays. Diagram shows piece of apparatus that can be used to determine the nature of the emissions from a radioactive source. The absorbers can be raised out or lowered into the path of the radiation. Okay, the apparatus is evacuated. The table shows, okay, so we have the radioactive source, we have different absorbers. These absorbers are thin paper, aluminum, and lead. Which types of radiation are being emitted by the radioactive source? So initially, the count rate was 350. When we put the thin paper, it was unaffected. And we know that the thin paper can stop the alpha radiation. So when the radiation was not affected, does this mean that we had any alpha radiation being emitted? No, no alpha particles were being emitted. So no alpha, because the reading did not change. When we put the aluminum, we know that the aluminum affects the beta, or can stop the beta. Was there any beta? Yes. Why? Because the reading did differ. So there is beta. Again, we know that the lead can't stop or can reduce the effect of the gamma radiation. Was there any gamma radiation? Yes, because the reading had decreased. So we do have some gamma radiation. No alpha. We do not have any alpha, but we have beta and gamma particles or gamma radiation only. Beta particles and gamma rays. Question 40. The half-life of a sample of radioactive material is 400 years. How long will it take until only 1/4 of the sample remains undecayed? 1/4 of the sample means what? Means 25% of the sample. Okay. Means that you divide it by 2 and then you divide by 2 again. You halved it 2 times. Okay. Quarter of the sample. Initially, for example, you had 100 milligrams. Divided by 2, it would be 50, and divide by 2 again, it would be 25. So this is a quarter of the sample, okay? Quarter of the sample. A half-life, one half-life for this sample would take 400 years. So basically, you need two half-lives. Two half-lives. Why two half-lives? Because you need to reach only a quarter of the sample, 25% of the sample. Two half-lives means that you will multiply 2 by 400, which would give you 800 years. So after 800 years, you'll have only quarter, okay, you'll have only a quarter of the initial sample remaining. Okay.